This video is about Hess's law. We use Hess's law when we're trying to find the enthalpy as the sum of several small steps, like shown in the question here. So the question is asking us to calculate the enthalpy change for the formation of magnesium oxide. So the first thing we have to do is let's find where magnesium oxide is. So magnesium oxide is right here. And from here, we can see that in order to make magnesium oxide, we need magnesium chloride and water. Essentially, there are just a few things you need to remember about the Hess's law. So number one, you can reverse the equation and this will change the sign of delta H. So what do I mean by this? For example, if this equation here is given to you, the formation of water, delta H is negative 241.8. However, if you're trying to find the enthalpy change of hydrogen, for instance, you take the negative sign here and it becomes positive because you're reversing the equation. So you're just changing the signs. Number two, you can multiply the equation by a constant, and then you have to multiply delta H by that same constant as well. So let's go through an example. If we're looking at this equation, and delta H is 285.85 for the formation of magnesium chloride and water. What if I want to find the enthalpy change for 4 moles of hydrochloric acid instead of 2 moles? We can apply both these rules here. Firstly, if I'm trying to find the enthalpy change for hydrochloric acid, I have to change the sign for this. So for example, if delta H is positive, I'm changing it to negative. Now I only have 2 moles of hydrochloric acid, and the question is asking me for 4 moles, for example. So what I do is I take this value and I times 2 so that I get the enthalpy change of 4 moles of hydrochloric acid. Now let's solve the question. So now we're trying to calculate the enthalpy change for the formation of magnesium oxide. It's here. So first we need to get magnesium chloride and water. So in the first equation here, we're forming magnesium chloride and we only need 1 mole for it. So it's direct. We just take this value and we use that. So we don't have to change the signs because we're not reversing any equation, and we only need 1 mole here. So next, we need water. So in the third equation here, it's producing water and 1 mole, so we don't have to times it by any constant, and we just take this value here, negative 241.8. Now finally, we need to make magnesium oxide. However, here, the value given to you is to form magnesium chloride and water, so we need to reverse the equation. And remember, when we reverse the equation, we change the sign here from negative to positive. It's positive 285.8. And now we add all these values together, and you will get negative 422.85. And don't forget your units, kilojoules. So this is the enthalpy change for the formation of magnesium oxide.